Queues are widely used in computer science. You'll find them in the architecture of operating systems, language runtimes, and even network protocols. But for most developers like you and I, when we talk about queues, we're usually referring to message queues, which is a type of compute offering that allows us to design resilient and distributed systems by having producers send data to a queue and then have separate services consume the data on a queue, process it, and send acknowledgements once the processing is successful. To better understand this concept, imagine you are building software that helps businesses send and manage booking reminders. The core feature of this software is that it allows businesses to connect their CRM, and then they can automate the entire process of sending SMS booking notifications. To make this happen, you build an API that listens for webhook events from a number of different CRM providers. This API collects booking and contact information from the webhook events, and then passes this information into a separate scheduling solution that you built. Before you can pass off the booking event to the scheduling service, you need to do a bit of pre-processing, like filtering out duplicate booking events, determining which business the booking belongs to, collecting metadata about the booking, and verifying the phone number of the contact with an external verification API. You could simply perform all of these operations when you receive the webhook event, but what happens when one of these operations fail? You can't guarantee that all the CRMs will try to resend the booking data if your API request is not successful. Which brings us to the use case for a queue. You simplify the design of your webhook API to collect the booking data, send this data to a queue, and then respond with a 200. Once the data is on the queue, you can design a simple consumer that performs all the pre-processing operations and then passes the processed data over to the scheduling service. You can even configure retry logic, so at any point in the pre-processing, if an operation fails, the queue will redeliver the message to the consumer a certain number of times. And if your system completely breaks down by having something like a database outage, you can configure a dead letter queue, which will receive the queue data after reaching the max number of retries. From here, you can always reprocess the data on the dead letter queue once your system is back online. So now that we understand message queues at a high level, let's get into actually building something on top of Cloudflare Queues. Now, if you're new to Cloudflare's compute platform, I actually have a course going over how to build an entire full stack application on top of Cloudflare. But the TLDR is Cloudflare offers a compute primitive called Workers, which is essentially a serverless runtime that supports various different full stack frameworks. To get started with queues, let's navigate over to the Cloudflare dashboard and create a queue. Now just note, I'm creating most of these resources via the Cloudflare dashboard, but you can also create these same resources through Cloudflare's Wrangler CLI. With that said, let's head over to the code. I'll make sure to share the link to this repo so you could follow along later, but for the purpose of this tutorial, I'd suggest just watching it through one time instead of just trying to follow along line by line. Notice this project is a monorepo with multiple applications. There's an application called user application, which is a Tanstack start service. This entire project is forked from a starter template that I actively maintain. The Tanstack start service is very simple. There's an input form that submits a message to a server function. To understand how to use queues, this server function is going to act as a producer to send a message to our queue. Now, let's head over to the wrangler.jsonc file and set up a producer configuration. You need to specify a binding name and also add the name of your queue. The remote field is optional and defaults to false, but I like to set it to true so I can run locally and send the data to the production queue. Now in your terminal, you're going to run the cf typegen command, which will generate your bindings for this project. Now, if you head back to the server function, you'll notice we're able to access the queue binding and send data to the queue. Let's deploy this application, go to the deployment URL, and then send some test data to our server function. Now, if we head back over to the Cloudflare dashboard, we can select the queue, go to messages, and list the messages that are in the queue. So this is really all that it takes to set up a producer for a Cloudflare queue. We could build out the consumer logic inside of our Tanstack start application and deploy them as one deployable, but I typically like to move the consumer over to a separate service called the data service. The data service is designed to be very simple and lightweight. We create a class that extends the worker entry point and out of the box has a fetch handler that just passes off a fetch request to a Hono API. To create a queue consumer, all you have to do is implement the queue method, which takes in a batch of messages. To start, all we're going to do is loop over the batch of messages and log out the message. Now, head over to the wrangler.jsonc file inside the data service and configure a consumer. The consumer configuration has a few different parameters, but the only required one is the queue name. It's important to note that a Cloudflare queue can only have a single consumer, but it can have multiple different deployed services act as producers. Let's go ahead and deploy the data service. After the service is deployed, go find the deployed data service under the Workers tab. Let's head over to the section where we can view the logs and turn on live mode so we can see the logs in real time. Now in a separate tab, let's head over to our deployed Tanstack start application and submit a message. After a few seconds, you should see the event sent from your user application logged out in the data service. So at this point in the video, we've successfully created a producer and a consumer. Now I want to dive deeper into more cool features that Cloudflare Queues offer, but before we do that, let's build out a handler for this event. Inside the message loop is typically where you're going to build out your custom business logic to process messages from a queue. As of late, I've really enjoyed using the effect library to build out the actual event processing logic. With that said, effect has a really steep learning curve, and I don't want to get too distracted in this video. So what we're going to do is define some Zod schemas to match the shape of the data that enters the queue. Then, inside of our message loop, we can go ahead and parse the message. We can then create a simple handler method that takes in our type-safe event. Now, usually this handler is an entry point to more complex processing logic, but for this example, we're just going to use Cloudflare's AI binding to pass in the message that the user sent over and then have an LLM generate a response. We'll also save the LLM output in a key value store so the Tanstack Start application is able to visualize it. From here, we just need to make sure our message loop is passing in the event to our handler, and then we can go ahead and deploy our data service. Now let's go over to our Tanstack Start application. You're going to notice after you submit a message that there's these polling requests in the network logs. We're simply calling a server function that checks the same key value store that we wrote to in our consumer. Now just note, I don't think that pulling a key value store like this is great design for various reasons, but I simply want to illustrate that we're writing data to a producer, that data is being consumed, processed, and then saved, and then we can actually see the saved result in our UI. So now after a few seconds, you should be able to see the processed output inside of our Tanstack application. Now that we are able to process data received by our consumer, let's take a look at one of the most underrated features of Cloudflare Queues. Event subscriptions allow you to receive messages when events occur across your Cloudflare account. In our Tanstack Start application, we have a component that allows us to upload an image and then save it into Cloudflare's object storage product called R2. In R2, we are able to configure an event notification that will send an event to our queue whenever a new object is created. We can then create a Zod schema with the same shape as this event. We can then create a generic queue message schema that unions all of our event schemas. We'll now update our message loop to use the generic schema. From here, we can conditionally render the events based upon the type found in the schema. I would typically create a new queue for managing event notifications like this, but I really just want to showcase that you can route events to their corresponding handler in a type-safe way. We'll now create a handler for processing the image stored in R2. We'll collect the file, convert it to an array buffer, and then we'll pass it into Cloudflare's image-to-text model, telling it to generate a caption for this image. We can then deploy the data service, head over to our Tanstack Start application, upload an image, and after a few seconds, you'll be able to see the caption that the AI generated. Now, this is a pretty basic example of how to use event notifications, but I do think that it's a really powerful feature that Cloudflare offers. I really like the fact that if I'm working on a really big project with a large team, I don't have to go update application code to send data to a queue if a corresponding event is able to capture that same type of data. Now, before we wrap this up, I want to share a few more cool features that Cloudflare Queues offer. When you send a message to a queue, you can specify the number of seconds you want the message to be delayed. An example of where this would be useful is if you're sending an SMS, you can ping the Twilio API, which will give you a message ID back. You can then send the message ID onto a queue, delayed for 5 minutes. 5 minutes later, that message will be consumed, and you can check the Twilio API to see if the message was delivered or not. In the consumer, you can also explicitly configure the max number of retries, a retry delay in seconds, and if all the max retries have been hit, a dead letter queue that will catch the event so you can process it later. You can also specify a max batch size and a max batch timeout. The batch size parameter indicates the number of maximum events that you want to be processed in a single batch. The timeout is the number of seconds that the queue should wait to deliver a batch if the max batch size is not met. Depending on your error handling strategy, you can manually acknowledge messages. So if one message fails in a batch, the other ones that are acknowledged will not be redelivered. At the message level, you can also see the number of times a message was attempted to be processed. You can also explicitly instruct a single message to be retried with a retry method. At the batch level, you're able to see the queue name of the batch in case you have a consumer that's consuming from multiple queues. You can also ACK all the messages or retry all the messages. So this about covers all the core features that I actively use when building out applications on top of Cloudflare using Cloudflare Queues. Now, I personally think that queues are underutilized in a lot of full stack applications. In my opinion, the true product of most SaaS applications live on the server, which is ultimately why I created the full stack on Cloudflare course. I wanted to showcase how you could use compute primitives like durable objects, workflows, and queues to create an end-to-end SaaS application. A number of people that took the course mentioned how much they love the project structure, which is why I also created the SaaS Kit, which is a free open source starter template, which I use personally to ship faster on Cloudflare. With that said, I really hope you find this content useful, and I hope it helps you build and ship faster.